I'm going to start with something called the universal set. And typically we denote it by the letter U in set theory, but oftentimes people use the letter uppercase S as well. Now, if someone wanted to know or wanted to identify these sets in the United States with respect to political affiliation, then hypothetically, I can fully partition that into 4 cases, hypothetically. I can say Republicans, Democrats, Independents, other. So every person, individual who isn't affiliated with either Republican, Democrat, or Independent goes in other. So if I take all US citizens and I ask political affiliation, they definitely will fall into one of these cases. Does it matter in which way I drew these things? In terms of shape, in terms of size? No. All I'm saying is the entire square can be partitioned into 4 and it covers the entire square. The full square, is it a square? Well, more or less, looks like a square, almost. The entire square would be US citizens. And that is what we call the universal set. But the universal set contains 4 different subsets. R is a subset, D is a subset, I is a subset, O or other is a subset. All of them put together forms U. That is one case, but typically a set needn't cover all US citizens. For instance, I could have a case where I have some universal set U, could be US citizens, could be the country Europe, could be Asia, could be anything. And some arbitrary set A is part of that universal set. Think about it this way. Universal, the universe, the entire universe. Is Earth a subset of that universe? Yes. So I can say, well, Earth is a subset of that universe. Is it right to say stars are a subset of this universe? Yes, it's part of it. Can I say all palm trees subset of this universe? Yes, certainly. And there are a whole bunch of things that are subsets of our universe. If you can find all of those things and put them together, you will get the entire universe. But I can't find all of those things because there are things that we don't know. So what we don't know is the space that's left unshaded. I'm about to shade it. So that's a set, that's a set, that's a set. Whatever that remains is the unknown part. If we can fill it all up, then I can say the universal set is made up of proper subsets. When put together, you get U. So case 1 of Venn diagrams is to represent disjoint sets. Disjoint would mean something that is not joined or connected. So if we want to represent two disjoint sets, set A, set B, and the two sets have nothing in common. They are not connected. And that's what we call disjoint sets. The next case is a proper subset. Keep in mind, a proper subset is one where a set is only or certainly a part of another set, but it cannot be equal to that other set. So I drew, a set A. Set B inside A is a proper subset because B is a part of the set A, and whatever that is left behind will be the universal set. The third case would be the complement. Complement would simply mean the opposite, something that is not. For instance, if I pick a set A, everything that's not shaded in U, the universal set, is a complement. Typically, people would put A and the tick as a superscript, or people might write it as A superscript C. Both of them are acceptable. Next case, case number 4, some commonality between two sets. I'll call it not disjoint sets. In other words, there is something in common between two sets. Oftentimes, people ask me, well, should I draw circles? Should I draw them properly in the center of the square? none of that matters. People pick circles because, you know, they look nice. Conventionally, Venn diagrams, people use circles and squares, but the purpose of a Venn diagram is to illustrate sets. So as far as I'm concerned, you know, I go ahead and draw whatever shape I can think of, and not necessarily circles. But circle is what people would always use when it comes to Venn diagrams. So here are two sets that are not disjoint. So I've got the set A, set B, and there is the middle part that is common to both. So clearly the sets are joined. So these are the sets A and B are not disjoint sets. The last case is trivial. I guess I'll go back to just A in this disjoint set. If you want to represent a set that is equal to itself, all you can do is draw a circle inside the universal set, because there's nothing else you can do. It's a trivial case. I believe the book goes over it. That's the notation of an equal set, because, well, that's the set A, and it's equal to itself. Again, it's equal to itself. You can see it's getting darker and darker in terms of the shade. So when I simply draw an empty circle, I'm just representing a set that is equal to itself for some set A. Do people use that representation often in practice? No, I don't use it. But since we are covering Venn diagrams, I'm just mentioning it.